Hi, today we're going to be talking about inductors and in the future videos, how we can use inductors in an electric circuit. So, an inductor takes advantage of the fact that current that flows through any conductor generates a magnetic field. So if we had a cable with current flowing in this direction, then we can use our right-hand law like this to see the current is flowing in that direction where my thumb points to, and the magnetic field around the cable would go in the direction of my fingers like this. So it would go around it and like this. So an inductor is actually a cable which is wound together on itself like this. So that when we apply voltage like this, we get current flowing in this direction, and then it would flow like upwards here, and I would get on each of these loops, I would get a magnetic field in this direction that will add up to the magnetic field of this direction and add up to the magnetic field in this direction, so that we would get a magnetic field, magnetic field lines going like this. Like this, in this direction, and around it, like this. So, applying a voltage into a cable that's wound to itself would generate a magnetic field like this. And this magnetic field will induce a voltage drop across the inductor. And that is essentially what an inductor is, and we can use inductors in electrical circuits. That what happens here is that inductors, basically what they do is they store current in the form of a magnetic field, because then the magnetic field will then induce a current as well, and then it goes back and forth like that. So basically it's an element that stores current in the form of a magnetic field that generates by the flow of current through it. The inductance of the inductor is represented by L, and it's measured in henries, which is written by an H, so it's the unit is the Henry. The unit of measurement for inductance is the Henry, and the inductance is directly proportional to the magnetic constant of the material that's inside it, because if I had, let's say, an iron core in here, then the magnetic field that's generated by the current flowing through it would be stronger than if it's just pure air there. So it's directly proportional to the magnetic constant of the material inside the coil, to the square of the number of turns, and to the cross-section area of the cable, so that if I have more turns, I also have a bigger inductance than if I have less turns. And in a solenoid like this would be a solenoid, basically making a kind of tube out of my wound cable. The inductance is also inversely proportional to its length. So, yeah, on the next videos we're going to be showing how to use this inductor, what the properties of an inductor is, and how to use it in an electric circuit. Thanks for watching.